Good afternoon. This is Kim McCleary. I'm President and CEO of the CFIDS Association, and I'm pleased that you've all joined us this afternoon for the 9th program in our 2010 webinar series. This is also the 3rd program on the association's research program itself, and many of you, it looked like about half of the group that had registered for today's program had participated in one of the earlier webinars on our research program. So we're delighted that you've come back, or if you're new for the first time and joining us for this particular topic, that you'll get an update on at least 3 of the 6 programs that we support. As well as some new information that Suzanne is bringing us from Japan, having been to a fatigue science meeting in Osaka 2 weeks ago. So before I introduce Suzanne and we get started with the program, I will just give you some sort of housekeeping tips for the webinar. More than half of the group, actually 80% of the folks who registered for today's program have participated in an earlier webinar. So we have a really experienced group with us today. So I won't spend too much time on this, but as I see people are continuing to join us, I'll just go over just a few things that kind of make webinars different, and so that everybody's aware of how to send questions. First of all, Suzanne and I are in different locations. We're actually both just back in our respective offices, having been in a meeting in Milwaukee earlier this week, but we're now in Charlotte and Colorado, respectively. The questions that you might have submitted with your registration were shared with Dr. Vernon in advance, and we'll try to keep those in mind as we move through the presentation. There is time for Q&A after she finishes her slides. So as you think of questions, please type them into the little dialog box that you'll find on the right-hand side of your screen in the little dashboard that you can see that has the GoToWebinar at the very bottom of it. And those come into me, and then I'll try to answer the ones that deal with technical issues like sound and where to find the recording and those kinds of things, and pass the other ones on to Suzanne. At the end of her presentation, we'll have just a little dialogue in response to the questions that come in during the program. As a reminder, we do try to record and post the recordings of these programs online. Those go onto our YouTube channel. It takes a day or so to get the file processed and loaded up onto the site. So if you want to listen to it again or share the URL with a friend, we will include that information, where to find it, in your follow-up email that will come to you in a day or so. And just as a final reminder, Dr. Vernon is a PhD, not an MD, and this format doesn't lend itself easily to addressing individual questions about medical topics or personal symptoms or treatment, even when we do have an MD with us. So just a reminder that we won't get into any personal issues about the illness. So without further ado, looking like we've got a good majority of the folks who had pre-registered with us today. It's my pleasure to introduce my colleague, Suzanne Vernon. She is the Scientific Director of the CFIDS Association, having joined our staff at the end of 2007. She holds her PhD in virology from now I'm going to get it mixed up because we were just in Wisconsin. University of Wisconsin-Madison. Not MCW, where we were yesterday, but studied under Howard Timon in the virology department at University of Wisconsin in Madison. She also earned her certificate in public health genomics, and she's very much a proponent and student of the systems biology approach to CFS, and has brought that expertise in sort of linking up all the disparate systems of the body into a unified model about how CFS might begin and be perpetuated and be explained by all the various findings that have been documented in the literature over the last 25 years. one of the talents that I think Suzanne brings to the association that's rather unique to her is an ability to take very elegant technical science and put it into language that even those of us who don't have a lot of letters after our name can understand. So it's been, a great asset to the community, I think, to have her able to help translate some of this science into meaningful language that we can all absorb. And she does it extremely well in this rather odd format of the webinar. So, so that I don't steal any more of her time or thunder, I'm going to turn it over to Suzanne. Suzanne?
Okay.
And I'm going to...
You're going to what?
Let's see. I realized I hadn't shown my screen yet. I don't think. Nope. There we go. Sorry, gang. Forgot to hit one last button before I got started. So anyway, you can now see Suzanne, and I'm going to turn the keyboard and the mouse over to her so that you can see her slides. And let her get started.
So as Kim indicated, we were both in Milwaukee over the past couple of days. I got home at midnight last night, and I think, Kim, you got in at something like 8 o'clock this morning from your lovely 6 a.m. flight.
Yes.
And I have been on teleconference meetings all morning, so have not gotten a chance to review the questions that have been submitted. So if you could kind of go through these as I'm going through my presentation, Kim, and maybe highlight some of the ones that you think are most important for me to address if they don't get asked in the meantime. How's that sound?
That sounds good.
Okay. So I have the controls. I'm driving, right?
Yep.
Can you see my first slide?
You have to hit the show my screen button.
Oh. Okay. Mute me. View in full screen mode. I don't have a show my screen button.
There should be one under the on-air showing screen.
I have a hide control panel, view in full screen mode.
See if that helps.
Audio, chat. Oh, my screen just disappeared.
Sorry, gang. Technical issues here.
This is no lie. Everything just went black. Did you just like kind of swoop in and take over my computer? It's not responding. It's a black screen.
Okay.
Oh,
Oops.
I have show my screen.
There you go.
So you did take control of my computer.
There you go. There's
enough dilly-dallying. Sorry about that, gang. But that's actually given time for a few more people to join us. So we have a good showing today, and I'm going to talk to you about 3 of the research projects that we are currently funding, and also some of the really interesting and exciting things that I learned about at the Japanese Society for Fatigue Science meeting that I was at a couple weeks back. So just as a reminder, I'd like to tell everyone or remind everyone about the $1 million research campaign that we launched in 2008, which was made possible by donations from people with CFS, their families, and supporters. And it was a request for applications that was aimed at proposals for discovery of biomarkers, methods for early detection, objective diagnosis, and effective treatment of CFS. So you guys have heard this before, but it's definitely worth repeating because you're going to hear about it again at the end, and this is exactly what Japan is doing right now. So, I mean, it seems that there's a nice convergence of science throughout the world. Page down. There we go. So again, by way of reminder, when we issued the request for applications, or the RFA, we received 33 letters of intent and invited 24 investigators to submit full proposals, and that invitation came because their letters of intent were in sync with the request for applications. We received 21 applications that were reviewed by 44 scientific experts that were invited to be reviewers from around the world. And then the top 9 proposals were evaluated further for strategic merit. And then from that pool, we ended up funding 6 proposals that met both high scientific and high strategic merit. I will be talking about 3 of those today. I think the last time I talked about the other 3, what was that, about a month or so ago, I talked about the post-infective fatigue by Gordon Broderick, the microbiome by Sanjay Shukla at Marshfield Clinic, and the computational biology, or the Google for CFS grant by the NYU group. And this time I will be talking about blood, a lot of blood proposals. So I'm going to be talking about the LIGHT team work, and that the LIGHTs are at the University of Utah Health Sciences Center, and I'll also be talking about Marvin Meadows' research at NYMC and Tacoma Shangu at Weill Cornell Medical College. So as I indicated, a lot of, well, these 3 studies today deal predominantly with blood. And I think blood is one of the most promising fluids that we can use to have to discover biomarkers that are specific for CFS. And that is because, as this diagram shows, blood flows throughout our body, from the tip of our head to the tip of our toes and fingers. It goes everywhere. So in that sense, it can be a fluid that is potentially holds molecules or indicators of various disease processes, no matter where they may be occurring in the body. In other words, it's a sentinel fluid. It can hold clues to disease processes throughout the body. And as you all know, our body, or the blood, is a very important, specific fluid that serves a lot of purposes, from transportation of nutrients and waste products to and from cells, to also serving as the medium for specific signaling processes that go on throughout our body. So not only do our nerves send specific electrical signals, but our blood serves as the medium for various types of chemical signals, again, to get information distributed throughout the body. So it's a very interesting and important fluid or medium, and in many ways resource for biomarker discovery and characterization, for characterizing objectively what's going on in CFS. So it is a fluid, but it's a very complex fluid. It's, you know, when we look at it, we poke our finger or we get blood drawn into a tube. It's this red fluid. But in reality, it's a complex mixture of both cells and fluid. So the liquid portion of our blood is called plasma. And there are a lot of various chemicals and molecules in the plasma that are important to study in many ways, or to discover, yet to be found. So, for example, cytokines are present in the plasma. And then we have the cellular component of the blood. And as shown in this diagram to the right, we have red blood cells, which are the kind of clear pinkish red discs. We have platelets. Platelets, as you know, are important in clotting, and they also carry them. So there are also little packets of chemicals that carry various chemicals throughout the body. And then we have the white blood cells, which come in a variety of forms. Agranulocytes, which are lymphocytes and monocytes, and they're called agranulocytes because in the cytoplasm of the cell, there's no little granules present. So when you're looking at them underneath a microscope, as in, sorry about that, guys. Can you see the blood picture now, Kim?
Yes.
Okay. As in this picture, right? There's a delay on my mouse. Sorry again. This picture right here is a lymphocyte. There's not much cytoplasm, but there you can see that this blue part is different than this part here. This is a granulocyte or an eosinophil, but there's actual little granules in there. But my point of showing you this is to illustrate how complex of a sample blood can really be. So when we talk about studying blood, there's a number of different ways to study it. There's a number of different ways to sample it. And there's a number of different ways to tease out the kind of information that we need from it. But it's a very important sample that, in fact, holds a lot of different types of information. So on top of the fact that blood is a complex medium, it also has a very dynamic existence. So it has to flow throughout the body. So it has to nourish the brain, and it has to nourish every single organ in our body, as well as the things that we don't necessarily think of organs, such as the skin. So it has to get, again, from the very top of our brain and throughout the brain into the very tips of our toes and fingers, as well as nurturing and keeping viable and healthy all of our various organs. And this is a picture over to the left corner that Marvin Meadow has shared with us on a number of occasions. And I think it's a very interesting and important one that we don't necessarily think about when we think about blood flow. And that's the effect of gravity. And as humans, we're upright human beings, and most of the time, quite a bit of our blood is kind of below the heart level. It's down here. It's just the fact of physics that a lot of the pressure and the gravitational pull keeps our body or blood fluid down below this level, down below heart level. So you can just imagine how hard, number one, and how effectively, number two, our heart has to work in order to maintain a blood flow that, in fact, does all the nourishing and the job that needs to be done in order to keep all of our body systems healthy. And this is just an example of, in contrast, a four-legged creature who has a nice little evenly distributed blood flow into the brain and actually to the rest of the body. So they're not as subject to the gravitational stresses that we are. So you've seen this slide before, those of you who have joined me on some of my previous webinars. When we think about biomarkers, we really have to try to determine which ones are the important ones? Where are the targets? What are the markers or the indicators that are going to help us get to an objective way to identify, to diagnose CFS? And also biomarkers that help us understand whether or not various treatments are effective. So over the 20 years or so that CFS has been studied, many biomarkers, potential biomarkers, have been identified. Few, unfortunately, have been either validated or followed up on. So what the intent of our RFA, or request for applications, is to really try to begin to consolidate, identify the most important biomarkers, consolidate them, and validate them, or provide the means to validate them so that we can move to an objective and effective means to deal with CFS. And in fact, this is a way to really, I think, maximize the investment of your research dollars, which have made this research initiative possible, to get the biomarkers from the bench to the patient bedside, actually into the clinician's office. It's a way to allow, to bridge that gap between the bench and the bedside. So we're focused on identifying biomarkers that will get us there. Next slide. So the three investigators that I'm going to talk about today are Kathy Light, and as I indicated, Kathy and her team are at the University of Utah in Salt Lake City. Sorry, I'm using a little touchpad and it's a little touchy. Marvin Meadow at the New York Medical College in Valhalla, New York, and Tacoma Shungu at Weill Cornell Medical College in Manhattan. So let's take a look at what's happening with each one of these investigators. Kathy and her team are studying ion channel markers or biomarkers on blood. Kathy collaborates with her husband, Alan, who's a neuroscientist by training, and with Cindy Bateman, the lead clinician of the Fatigue Consultation Clinic. And together they have put together this study along with some investigators in Kathy and Alan's laboratory to really characterize a set of markers that, as you will see, appear to be good candidates as objective markers for not only CFS, but for subtyping CFS and potentially for giving indications of efficacy of certain types of treatments. Now, let's back up a little bit and talk about the sympathetic nervous system, because the markers that Kathy and Alan and the Light team are studying are markers that were originally characterized in the sympathetic nervous system. Remember, I told you that Alan Light is a neuroscientist, and he has actually spent most of his career studying the sympathetic nervous system and identified these markers as on nerve cells as indicators or markers of pain and fatigue. And he conducted some experiments that indicated that perhaps these markers were also expressed, these nervous system markers were also expressed on other tissues. So when he made that finding, he then looked on blood cells to see if, in fact, they were present there. And as you will see, in fact, they are. But what is the sympathetic nervous system? The sympathetic nervous system is one of the arms of the autonomic nervous system in general. So if we think about the central nervous system as our brain. The autonomic nervous system is the kind of the peripheral part, or from the neck down part of our nervous system. The nerves innervate all of our organs and up to the tips of our fingers, etc. So it's an extensive network of nerve tissue that basically allows our body to function, in the case of the autonomic nervous system, automatically. In other words, not a conscious effort. So it helps our heart function, it helps our gut function, all of the organs that need to help maintain our body system balance. The sympathetic nervous system is the one arm of the autonomic nervous system that is important for mobilizing the body or responding in a fight or flight situation. So if you are all of a sudden scared, or you get an infection, these are the types of stressors that mobilize the sympathetic nervous system or induce it. However, it's important to remember that not only is the sympathetic nervous system a responsive arm of the autonomic nervous system, it's also one that's active at a basal level all the time, and this is important to maintain body homeostasis. So the markers that the lights originally described are these. Let me see if I can use my mouse without making my slide go crazy right here. So this yellow stringy blobby thing is actually a nerve, or a schematic of a nerve. And these receptors here, these other nice little kind of flower-like objects, are receptors that are responsive to ions. So sodium ions, hydrogen, protons, they combine and they actually go to these receptors, enter into the nerve ending, and then stimulate electrical activity. I think I removed the animation to this. Sorry about that. These little molecules, I think, move all over the place. Let me see if I push the down button whether or not it'll happen. Oh, it does. So that was a proton going and binding to these ion channel receptors called ASIC receptors. And then you'll see the ATP, some little energy molecules going and binding to these P2X receptors. And then that allows sodium into the channels. And that sodium gradient then induces an electrical signal that travels up to the brain and says, respond. So essentially that nice little cartoon shows the activation of a nerve ending and how that happens. So ions out in the liquid part of our body outside the nerve enter through these channels and then induce an electrical signal. This is what Alan studied before he actually started studying these same markers on blood cells. Okay, so they then looked at this a little bit further in the context of, remember that picture of the sympathetic nervous system where you have this network of nerves throughout the body sitting very closely to all of our organs, helping the organs work. This is a picture of a blood vessel. And this shows, again, those same types of ions, those same types of chemicals entering into a blood vessel via a nerve ending. Think about those sympathetic nervous system nerves that are cozied up to all of the organs and blood vessels. This signal then goes up to the blood, or into the blood, up to the brain at the same time. And then the responsive signal from the brain comes back down, activating other types of receptors on nerves. These are the afferent receptors on the nerve cells, on the sympathetic nerve cells. causing the release of various adrenergic molecules into the blood system, and again, helping with this fight or flight response. So I think what this schematic, what this animation shows, is that it's a number of different types of molecules, a number of different types of receptors, both on sensory nerve endings and in blood vessels and in blood cells, that end up being required in order for an effective response to occur. That's a very weird blow-up animation there. So how does the light team actually test for these receptors on blood? They are using an exercise model, and this is an Airdyne bicycle that they use. They enroll patients with CFS and matched controls, and these are controls matched by condition, by age, by race, by sex. And they're also looking at a disease control group, and this is a multiple sclerosis control group, because people with multiple sclerosis also experience fatigue. However, the difference is that people with MS do not have a post-exertion fatigue, which people with CFS, in fact, experience. So they put the subjects, or all the participants, through this exercise paradigm. Blood samples are taken before the subjects get on the bike, and then at 4 times afterwards, a half hour after the bike, 8 hours, 24 hours, and 48 hours. At each time a blood sample is taken, and throughout the exercise and following the exercise, various types of assessments are also taken. How much pain is being experienced, how much fatigue is being experienced. They also take a lot of oxygen and heart rate measures, etc. And this is a picture of the blood that's taken at these 5 times before and after the bicycle or the exercise challenge, in order to assess what's going on with these ion channel receptors. So this is a graph showing the types of molecules that they're measuring on blood cells now. These are the sensory receptors that they characterized on nerve cells that they're now measuring on blood cells. These are sets of adrenergic receptors that they're also measuring on the blood cells. And then these are the immune markers that they're measuring on the blood cells. When they look at their control population, the baseline is here, and then 30 minutes after exercise, 8 hours, 24 hours, 48 hours, there's a little bit of activity going on in some of these markers over time. Nothing to knock your socks off, though. This is what happens in CFS patients. So here's before exercise, 30 minutes, 8 hours, 24 hours, 48 hours. A tremendous difference, a tremendous upregulation of these various receptors in blood cells in CFS patients. And this is a population of patients that have comorbid CF or fibromyalgia, in addition to those without fibromyalgia, or just not CFS without chronic widespread pain. What happens in the disease control group? So remember, I told you that people with multiple sclerosis also experience fatigue, but they do not have the characteristic post-exertion fatigue. And this is what it looks like when MS patients are put through the same exercise paradigm. Before exercise, 30 minutes, 8 hours, 24 hours, and 48 hours after exercise. Very little indication that these markers are affected. So fact, they are very similar to the control patients. So these markers look very promising as far as being specific for CFS in a diagnostic way, potentially, and also in a way that can be used to assess response to treatment. Now, this work was preliminary and was actually published back in December of 2009, and the Lights have finished enrolling all of the patients and controls, both disease controls and healthy controls, and are in the process of doing their final bits of analysis. It appears that this finding has held up. That it's been reproduced. They've validated it, and they're in the process of actually filing some intellectual property to commercialize this test or these sets of markers in order to get it to the market so that physicians can use it. So we're very excited about this finding, and we look forward to hearing the final round, the final report, which we hope to see, I think, by the end of the year. I just also want to say, too, that because of the recent events of how quickly information can spread via the internet once a presentation is made, I've chosen not to present some of the more recent information that the investigators are required to report to us. So I'm keeping some of these reports confidential so that they don't necessarily make it out to the World Wide Web before the investigators have a chance to publish them and report them on their own. So again, these biomarkers were helped, the Light Team biomarkers were helped by providing an objective test that differentiates CFS from controls, and that's both from healthy controls and potentially other types of disease controls that have a fatigue component. It also is looking like these markers will differentiate certain types of subtypes of CFS. So there's a little bit of gradient between these markers with people that have CFS and fibromyalgia and those that only have fibromyalgia and those that only have CFS. So it's a potentially important subtyping tool. And then there's also some indication that these markers can be used to quantify response to various types of interventions and treatments. So some very important, intriguing, potentially important biomarkers for us to have hope for in the very near future. Moving on to Marvin Meadow. Marvin is actually studying blood flow. And he and his team at NYMC, along with Julian Stewart and Ben Nadelson, work, and he's also working, this team is also working with the Weill Cornell team, Tacoma Shungu's team. They study blood flow by utilizing the tilt table. They also look at cerebral blood flow by using this transcranial Doppler. So this is essentially a Doppler radar that measures the arterial pressure in both a laying down and an upright position. And then they also look at the blood flow in the capillary beds underneath the skin, and that's shown right here in this picture, where a very, very fine tube is inserted underneath the skin, and then the Doppler, what's my pointer again, the Doppler can actually assess what's going on, what types of chemicals are interacting with the wire that's inserted in this permeable tube directly underneath the skin. It's a great way to measure oxidative stress markers. Now, the interesting thing about the Meadow team is that they specialize in the autonomic nervous system, and in particular in postural orthostatic tachycardia syndrome, or POTS. And what they have observed over the years of study is that the majority of patients that they see, the CFS patients that they see, also have POTS, or postural orthostatic tachycardia syndrome. So their study includes both CFS patients with POTS and CFS patients without POTS. And that's just, I think, in many ways the nature of the beast. POTS turns out to be something that occurs very commonly in people with CFS. So how can we use some of these characteristics of POTS, or disturbances in blood flow, to help us understand the pathophysiology and objectify the diagnosis of CFS? This is what they're working on. And again, just a reminder that this is essentially the information that the Marvin Meadow team is capturing. And this is capturing information on autonomic nervous system function. So when they are assessing the blood flow, they are essentially getting assessments of how well the blood is allowing the organs to function by looking at oxidative stress markers, by looking at various chemicals, and by looking at how well the blood is flowing up to the brain. This is an assessment of autonomic nervous system function. What they have found to date, and again, this study is also wrapping up with its enrollment of CFS patients and controls. They have found that in CFS patients with POTS, that there is a decreased upright cerebral blood flow and a decreased cerebral autoregulation. So what does that actually mean? Let's look over here under the control panel. And this AP on the y-axis stands for arterial pressure. So this is a measurement of that transcranial Doppler, where the little electrode is put on the side of your head. This is in a laying down position. And then this is when it's tilted up. So this is what it's supposed to look like. This is what pressure is supposed to look like when you're healthy. Lying down and then tilted upright. And this is cerebral blood flow velocity, lying down and then upright. Now, if we go over here to someone who has CFS and POTS, here's what arterial pressure looks like when they're laying down. Quite different, a lot more organized in a way than over here in the controls, which looks a lot more, a little faster and a little bit more chaotic. And this is what happens when the person is tilted upright. Again, very distinct from the control individual. Over here, and this is what cerebral blood flow looks like. Again, compared to the control, very almost quiet in someone with POTS. And then this is what happens when we tilt it upright. Now, I think the thing that is interesting was actually one of the major findings of this, is that look how similar over here on the POTS side the arterial pressure and the cerebral blood flow look. They look quite similar. Whereas over here in the control, they're actually a lot more chaotic. They're not in sync. That's a key point. They're not supposed to be in sync. The blood flow dynamics in the brain are independent from what happens in the body. That's how come our brain can somehow keep functioning no matter if we're in a standing or a sitting position. It's not dependent on what's going on in, you know, on gravity or on our position, as, you know, well, it's not completely independent, but it's not totally dependent either. Whereas here, over in POTS, some of that independence is lost. So the auto-regulation, the ability for the brain to auto-regulate the blood flow is lost in patients with CFS and POTS. So this is a very important finding and something that I hope we're going to understand much more comprehensively and conclusively at the close of this study. And it appears that, again, this finding is a reproducible finding and one that has the potential to serve as a very important biomarker for CFS patients and blood flow. And again, this is one that can not only be an objective indicator, but also can be one that is used to assess various types of treatments in CFS. You can imagine that when a person is undergoing various types of blood pressure treatments or treatments for orthostatic intolerance, that these are some of the things that can be measured in order to see if that treatment is having an effect or not. Again, objective measures for treatment are almost as important as for diagnosis. So that's kind of what I just said. Finally, for today, I wanted to give you, well, I can't actually give you an update on on some of the latest findings from Dikoma Shangu, other than to tell you that they have another paper in press in a very high-profile journal that has replicated this finding of increased lactate in the brain. And let me qualify that by saying that this is lactate in the cerebral spinal fluid in the brain, in the ventricular space of the brain. So if you look over here to the top left picture of this brain slice, this is where Dikoma Shangu and his team found that lactate was actually elevated. So that's in the brain fluid. There's cerebral spinal fluid, not in the brain matter. When they looked at a number of CFS patients, patients with general anxiety disorder, and healthy volunteers, they found a significant difference in lactate levels increased in people with CFS compared to those with general anxiety disorder and healthy volunteers. They've expanded this study and they've included another disease control group. So this is another study that's used an important disease control group. And this is actually what's in press, and I guess I will say that it looks like this finding of elevated lactate is holding up again. So what does elevated lactate mean? Lactate, high levels of lactate, particularly in the brain or in the blood, is a marker of anaerobic glycolysis. In other words, think of when you exercise and your muscles begin to burn or ache. That is a buildup of lactate. Your muscles are switching to another form of metabolizing energy. And elevated lactate in the brain is an indication of that shift too. The body, or people with CFS, are actually trying to utilize or generate energy via different pathways. And that's an important little tidbit to remember, because the Japanese are actually finding the same thing, and I'll get to that when I start talking about some of the work that I learned about when I was in Japan. What does elevated lactate actually mean or imply for the rest of the system, the body system? How could that explain CFS? So what Dacoma and his team have done is put together, I think, this really nice model that fits together a lot of the system perturbations that we see and now understand contribute to CFS. So if we go up here into the left-hand corner, what Dacoma hypothesizes is that elevated lactate in the cerebral spinal fluid comes from some type of initial insult to the body, whether that be an infection or some type of immune dysfunction that results in an oxidative stress state. In other words, oxygen radicals or other types of chemical reactions that become antagonistic to the blood result in the generation of chemicals that are essentially toxic to mitochondria and also to our blood vessels. So they end up resulting in vasoconstriction, which could result in decreased blood flow to the brain, which causes, if you have decreased blood flow to the brain, you have a much more anaerobic or less oxygen-rich state in the brain, which could result in this increase in lactate that we see. And, gosh darn, sorry about that, guys. And it could also affect mitochondrial function, which, as you all know, mitochondria are our energy workhorses or our energy production organelles of the cell. They produce energy, or ATP, which allows us to perform work or to function. It's actually the process that's essential for homeostasis. So lactate ends up being a marker, an end marker of potentially an initial insult that could be something like infection or immune dysfunction, but it also is an indicator of a number of different processes that are going wrong or awry along the way. So potentially very important marker, and I think another important thing to say about lactate and measuring it this way is that this is a completely non-invasive procedure. You know, if a person gets into an MRI tube or an imaging device, and then these things are, these metabolites can be measured. And these are all essential metabolites or nutrients that are important for again, energy production and body balance. Can we, let's try to, let me back up a little bit. Let's try to tie together all of these three studies. Can these be explained by one or a handful of starting points or causes? In other words, can infection explain the multiple system perturbations that I've just told you about that we know exist in CFS? And the simple answer is yes, it can. So it can be a viral infection, it can be a bacterial infection, it could be something that results in an activation of the immune system. This is a diagram that was put together by Marnie Silverman, who's a postdoc at NIH. I think a very insightful postdoc. And what she showed, or what she hypothesized, is that an infection that causes our immune system to respond to it also affects the brain. Oh, goodness gracious, sorry about this. Also affects the brain, the HPA axis in particular, because of the secretion of various types of cytokines or modulatory chemicals that affect brain function. And these important feed-forward and feedback mechanisms, now the brain talks to the adrenal glands, which then produce cortisol, glucocorticoids, which then talk also to the immune cells and tell the immune cells to either stop producing what they're producing or continue produce. Oh, goodness gracious. Kim, maybe you want to take control of my, can you do that?
I don't have it on my system.
Okay. No, where was I? Okay, so anyway, these something as simple as an infection, which our body must respond to, can in fact cause a number of different system perturbations, whether it be vasoconstriction or decreases in blood flow to the brain, to various types of inflammation that results in joint pain and or fatigue. So again, yes, an infection or a triggering event that somehow activates our immune system to respond in a certain way has numerous potential consequences and can affect numerous potential body systems. So I think by studying the various types of systems, whether it be looking at the brain or looking at blood flow, studying the immune response, we, in essence, will generate a very comprehensive picture of how ultimately to, number one, be objective about how we can measure and diagnose CFS, and also think about or develop various very specific types of intervention strategies which help us to treat CFS effectively. Not just treat the symptoms, but effectively intervene at various types of targets or points in this system that is clearly perturbed in very many places. So in other words, you have to have a comprehensive picture in order to be able to begin to identify those targets, those exacting targets, which will help us be able to deal with CFS much more effectively. Kim, what time is it? How am I doing on time?
It's 2 o'clock.
Oh boy. Okay. Let me just give you a nice little overview of what I learned at the 6th Japanese Conference of Fatigue Science. Many of you may be familiar with the name Dr. Hirohito Kurosani. Dr. Hirohito Kurosani was in CFS from the get-go, and he is currently the president of the Japanese Society for Fatigue Science, or JSFS. In fact, he was the first one to identify CFS in Japan in 1991, and that was following the 1988 case definition. Dr. Kurosani is a physician at Osaka University Medical School, where he now has a practice that sees more than 2,000 CFS patients. So that case definition in 1988 was actually responsible for him identifying the first case, and obviously identifying and helping many more patients since that time. In April of 2010, Dr. Kurosani was awarded a 3-year grant from the Ministry of Health and Welfare to identify objective approaches for diagnosis and treatment of CFS. And that was was really what this meeting was all about. Actually, 2 days worth of presentations that illustrated the approach that they're taking in order to achieve this 3-year grant successfully. Before I tell you a little bit about some of the sessions, about some of the work, I actually spoke to Dr. Kurtzani about his belief of whether or not what they have in Japan is the same as what we have here. Because in the scientific and medical communities, I think there's actually a lot of doubt that the CFS in Japan is the CFS that we have in the United States. And he kind of looked at me and he was puzzled and he said, no, it's the same. It's exactly the same. We may have some different triggers, but what I study and what I treat is the same. And so he shared with me the paper that that defines CFS, that he uses and the rest of his team uses to identify and define CFS. And that's shown in Table 1. And I think it's actually a very nice, succinct way to define CFS. So there's 2 major criteria, which are a requirement in order to have a Japanese definition of CFS. Number 1 is chief complaint of 6 months of fatigue, and number 2 is to exclude the conditions that can explain the fatigue. So that's the medical exclusion. Then there are, I think it's 6 or more, yeah, 6 it says at the bottom. For the minor symptoms, 6 or more of those 11 are required in order to meet CFS criteria. And then the bottom are the signs, and they call that the physical criteria. And you have to have 2 or more of those signs or physical criteria: low-grade fever, pharyngitis, or lymph node swelling. So if we were to compare this to the HOMS, the 1988 criteria, or the 94 criteria, or the Canadian criteria, there's actually a significant amount of overlap in these, and I think a very nice way of screening and identifying CFS very effectively. In Table 2 is a score that they use. It's called the PS score, and PS stands for performance status. And you'll see a list of 10 conditions on the right, and then a score of 0 to 9 on the left. If you score 3 and above, that is an indication of the severity of CFS. A very simple and elegant way to kind of quantify the severity of the CFS in a very systematic and regular methodologic fashion. Everyone in Japan that studies CFS, and whether that be a biomarker study or a treatment study, uses this performance scale to assess the severity. So I think it's important for us to realize that what they are studying in CFS may have some subtle differences, but in general, the CFS that they are capturing using this definition and this severity scale are very similar to what we are looking at. I would think are very similar to what we're looking at here, although obviously we haven't done the bigger study yet to compare our patient populations, but something that we actually talked about doing. So what are some of the highlights from the meeting? They have a keen focus on biomarkers. They have a 3-year time frame to identify biomarkers for objective diagnosis and treatment. And they are focusing on the metabolome. Now that's an ohm word for assessing body metabolism. And so far, what they're finding is energy utilization differences in CFS. No big surprise, I know, but in fact, they are now zooming in on specific metabolic cycles in the body that are different. And they have found differences in the TCA cycle in people with CFS in Japan. And there are specific pathways in the TCA cycle that they're finding are different, and I think we're going to be reading about those real soon. They're also studying genomics and are identifying specific pathways using gene expression as well as genetics to show that people with CFS have decreased energy production, have alterations in antioxidation pathways. Again, think about what I showed you in Marvin Meadows' study, where they're looking at oxidative stress, and in Tacoma Shangu's, we're stateside finding the same thing that they're finding, disturbances in energy production and disturbances in oxidative stress pathways. They're finding decreased T and NK cell receptors on blood cells. And they're also finding an increase in antiviral response and iron use in using some of their genomic methods. They're also starting a very large proteomic effort, and while they have not yet gotten to the CFS samples, they're essentially establishing or building the foundation of the proteome, and this is now, the proteome is the protein catalog of serum, which is a really nice kind of set of potential biomarkers that can differentiate people that are sick from healthy. So they're starting by building that human proteome so that eventually they can look at serum from CFS patients and identify the differences, the protein differences, and establish effective treatments based on those differences. Now, importantly, a big component of their effort is a combinatorial one. In other words, they're not just looking at these fields independently. They are combining findings from genomics, proteomics, metabolomics, and creating these indices that can be used in the clinic. So in other words, a metabolic marker combined with a genomic marker combined with a protein gives them an index of a person's CFS state as well as the potential severity, because they realize, as I think many of us now do, that it's not going to be just one biomarker. It's likely to be a combination of biomarkers that is going to describe the CFS state. One of the really neat things about the Japanese is that they don't stop with the academics pursuit. They find something that's interesting and potentially important, and they market it. I mean, they literally jump from the bench, that finding, to making it a tool that clinicians can use in order to be able to deal with the clinical situation. And this is just an example of the Shino test, which is a test that looks at these biopyrins. And biopyrins are an end product of oxidative stress. So again, we talked about oxidative stress. We talked about how oxidative stress is plays a role, has a role, occurs in people with CFS. While it may not be specific, it can be an indicator of an illness state, and that's exactly what they are doing by packaging and producing kits such as this biopyrin kit, so that so that, again, physicians have at hand ways to basically objectively assess patients' status. And this is just an example. There were many examples of interesting findings that were being made at the bedside and almost in real time. Little groups would spin off and try to capitalize on that finding or commercialize that finding, so that there's very little downtime from discovery to actually getting something into the hands of people that can make a difference with it. I thought that was very exciting, and I think something that we can actually benefit from by a relationship with the Japanese team. Some other highlights were developing very sensitive assays to detect viruses in blood. And not that they were using these viruses as causative agents, but again, they were using, in this example, HHV6 as a biomarker. And it is a biomarker or an indicator of something out of balance in CFS patients. So in other words, more severely impaired CFS patients had higher levels of HHV6. But this particular assay used a chemical that was isolated from a particular type of plant and incorporated into an assay that allowed very, very low levels of HHV6 to be detected. So when they compared this highly sensitive method to the conventional method, they went from having maybe, I think it was about 50% detection rate to practically 95% detection rate. So the sensitivity of this assay was very, very good, highly improved. And that little graph over on the left actually shows that by measuring, this is a genomics plus a viral load assay, they can distinguish people with CFS in the blue from the healthy people in the green quite readily. So it appears that they're really on an impressive trajectory to objective means of identifying and quantifying CFS and also dealing with it, treating it. They have a huge effort in the autonomic nervous system using some plethysmography, which is, again, assessing blood flow and heart rate variability and total power to really get a handle on what's happening with the autonomic nervous system in people with CFS. And they showed some interesting data of how perturbed the autonomic nervous system is, really reflecting a great deal of orthostatic instability in the Japanese CFS population compared to healthy controls. So I think I hope this convinces you that, in fact, we are looking at some of the same things, and we're looking at the same things because the same types of differences or perturbations, system disruptions are apparent in the Japanese CFS population as in the CFS population. There might be some subtle differences, but the fact that we're looking at the same domains, I think, is indicative that we're kind of wrestling with this same elephant. And I think the most encouraging thing is that our objectives are very much the same. We're looking at trying to identify these objective markers so that we can get to more homogeneous subpopulations or subtypes of CFS that we can then effectively intervene with. We're doing this in the United States. They're doing this in Japan. I think by establishing and working together much more effectively or learning from each other, we're going to get there at a lot sooner than if we weren't. I want to close by just reminding everybody that I did talk to the Japanese. I gave a presentation on what's happening stateside, and I also told them about our biobank. And boy, are they interested in running some of their assays and using applying to use some of the samples that are in our biobank to run against some of their various assays. So I'd just like to remind everybody that we have an open enrollment for our biobank, and check us out. Check out the biobank. Go to www.solvecfs.org. Enroll. The general enrollment criteria is quite open. If you've been diagnosed with CFS by a physician, you are eligible to enroll in the biobank. So I'd like to thank you for your time and attention. I hope this was of interest to you guys, and I look forward to maybe answering some questions now. Right, Kim?
Yes, I'm going to hope that my sound will work. I know I was echoing at the beginning, so I'm going to try to manage my microphone so that doesn't happen. Suzanne, actually...
Wow, everybody's stuck with us.
I know. It's amazing, and we're past time. But will you keep your slides open? Because a couple of the questions were about specific items on the slides.
Did it go away? Did my slides go away?
It disappeared for a second, but it's back now, but it's not in full view mode.
Slide mode? Okay. Which slide?
So the one, the light study.
Okay. Let me go down to it.
One of the questions,
first
of all, you can answer this without the help of a slide. Do you know if patients with POTS are excluded or disqualified from the light study?
That's a great question. No, they are not. And one of the things that we've talked about, that is the lights and Julian Stewart and Marvin Maddow, is whether or not these same blood receptors are upregulated when a person is tilted, for example. So is it the exercise that is inducing the expression of these markers, or is it the upright position during exercise that's inducing these markers? We don't know the answer to that, but the cool thing is we have samples from the patients that Marvin's looking at and the patients that the light team's looking at. So one of the nice things about having this team of investigators or this research network is that we can validate, and that's part of the method behind our madness, we can validate these markers on the various studies.
Okay, somebody asked the pink lines in the CFS graph. Do you know if those correlate with symptoms, or have they had a chance to do those analyses yet?
They did. Now, I don't think they correlated individual markers, but they are in the process of doing those analyses right now. And in fact, they do appear to correlate with severity. Some of these. I'm not sure exactly which ones, but some of them do correlate with severity. And that's a good point, because that will also show the utility of these markers for identifying specific subtypes of CFS based on severity or based on comorbid conditions such as fibromyalgia. But we have the data to do that.
Great. And your slide where you kind of synthesized all of these studies into one model after the Shungu data, you can jump to that one.
Now, if I would have had time, I would have put together my own model instead of snitching Marnie's, but this actually captures it pretty nicely.
Okay, the questioner asked why the lines from the adrenal gland are different, red dashed or blue.
Because those are different cell types. So glucocorticoids or cortisol has varying effects depending on the tissue or the cell type that it's acting on. So what cortisol does is it goes into the cell, and then it actually functions as a nuclear molecule. So it goes into the nucleus where there are specific types of places where it can bind, and then depending on where it binds and what type of cell it binds to, it has varying effects. So in the case of that dashed line, it has an inhibitory effect. In the case of the solid line, it has a much more inducing effect.
Okay, there are several questions here about XMRV that I'm going to defer until next week, because next Thursday we have Dr. Vincent Racaniello, I think is how he says his name, from Columbia University, who's going to share with us what we know about XMRV, the agent, and then Dr. Lucinda Bateman from the Fatigue Consultation Clinic in Salt Lake City is going to provide kind of an overview of what XMRV research has done for CFS. So if you sent in
can I say one thing?
Sure, absolutely.
Can I say one thing? A while ago, Court Johnson actually asked me if I thought a virus like XMRV could alter the many systems that are altered in CFS. You know, could it hijack the immune system? Could it affect blood flow? And, you know, again, that's part of the reason for putting this up, and the answer is yes. You know, viruses that we end up living with and dealing with that aren't cleared from our body, like EBV, like HIV, have many consequences on how our body functions. And in fact, we know that people with HIV that are being effectively treated with antiretroviral therapies, in fact, have numerous endocrine, neuroendocrine disturbances that still have to be dealt with. So, yeah, these viruses that we get stuck with for life are tricky, and the body ends up having to compensate in multiple ways in order to deal with them and try to keep the body in some balance. I hope that wasn't out of line, Kim, but no. I think it's important.
And I should also just add that sort of the current explosion of information over the last week or so about XMRV is making many of the people studying it more reluctant to talk about it outside the pages of peer-reviewed journals. So we'll continue to try to bring you as much information on that topic as there is to bring. And I feel fortunate that we already had this webinar lined up for next week, because I think the timing will be quite good. Let's see. There's an interesting question here. What is different about the Japanese medical culture that allows them to do translational work, lab to clinic, faster than we can here?
You know, they're very motivated to work. I think that's probably the bottom line. I mean, it is a society a culture that thrives on success and working. So I think they see illness as impacting the well-being and of the nation economically. I mean, that sounds kind of cold, but I do think, can you articulate that a little bit better, Kim? But it's a very work-oriented, productive culture.
Yeah, and I think they have recognized the economic impact of CFS. on their culture, something that although a few important studies have been published in the United States about the $25 billion annual impact on the United States economy of CFS, that really gets the attention of the Japanese government in a way that unfortunately it hasn't here. And also I think there's just more energy put into bridging the gap between science and the pharmaceutical companies and the food companies. You know, from the trip that Suzanne and I made to Japan a couple of years ago, it was really impressive to see how many different industries were involved in supporting the work of Dr. Kurutsani and Dr. Watanabe's group. You know, they were designing living situations that would be as low energy as possible. They were looking at different foods that could give energy. And that,
yeah, and they still are. There was even more of that this time. It was unbelievable. The nutrition, what did you call it? The food, anyway, the food industry was just there at this meeting in full force. And I mean, it really is, they don't want people to be sick. They understand that people do get sick, and I think they take a very forward-looking preventative approach to it by trying to understand what the things are that cause illness, fatigue, prolonged fatigue, chronic fatigue syndrome, and then making it so that it doesn't happen, so that the rate of all of these illnesses is much lower. So that it is a very integrated approach from preventative all the way to control. I mean, it's just absolutely beautiful. But I do think it's because, like you said, Kim, it's a really economically bottom line driven society. People are happiest when they're healthy and working and contributing to society, and that happens in a state of health, not in a state of illness. I think that's a universal phenomena, but the Japanese really make it work.
And one of our participants is a Japanese major, and she just has added that it's absolutely true. Economic impact is very important to the Japanese, much more so than the individual careers of researchers, since the Japanese are much more group-oriented than we are. And,
perfect.
And there was also a question about how much of the Japanese research is available in English translation. Not enough,
I actually,
I think.
well, some of it was in English, and then they sent me a number of translations, but they wanted all of them to be kept confidential. They have some very, very exciting things happening. I'm not kidding you guys. It was a very exciting meeting. But they asked me to promise to keep what they shared with me confidential, and I'm keeping that promise. But stay tuned. I think there's just some exciting things coming from the East.
And a couple people have asked if they're looking into XMRV, and they are indeed, although those results are not yet available.
That's right. They will be presenting those results at the September 1st XMRV International meeting at NIH. But Dr. Kurutsani is working with the Institute of Virology, and I think it's in Kobe or in Kyoto. So he's again assembled a very impressive team.
Suzanne, if you wouldn't mind switching the controls over to me, and I think we should probably wrap up. It's 2:30. We've gone past time, and unbelievably, almost everybody who logged on at the beginning is still with us. So
that's amazing.
It is. It's very impressive. Thanks, guys. It's been great to see the support for these webinars, not only the live activity like we are doing right now, but also the recordings that are available on our YouTube site and how often those are accessed. And Suzanne, several people have asked me to pass on to you their thanks for your response to last week's XMRV study that was published in Retrovirology. And several people have sent thanks for traveling to Japan to bring back this research. And one of the functions that we see is being a bridge between that really well-coordinated research group in the U.S. because they're sort of the Rodney Dangerfield of the CFS world. They don't get that as much respect as I think they're due. And Suzanne's been over there 3 times to make sure that we're at least involved and engaged in the exciting work they're doing over there.
Yeah, and I think we actually talked about how we can more effectively, bring what they do in Japan to the world, and they're quite a humble group. So they're very appreciative of our efforts to bring what they're doing to the bigger picture.
And there were.
I didn't do anything. You took back the screen.
Yes, I did.
Yourself.
Yes, I did. I just wanted to make folks aware of the upcoming webinars. We've already mentioned the one next Thursday on XMRV specifically, and then we have a little bit of a break. And August 12th, we'll follow with Louis Katz, who is one of the world's leading experts on blood safety and transfusion medicine, who's going to join us to talk about blood safety and XMRV. And after that, we've got Max Sasser, who is a disability lawyer, and his practice has assisted many, many CFS patients in securing their benefits from the Social Security Administration. So I think those are 3 very high-interest topics coming up in the next few weeks, and we hope that you will join us again. And again, thanks everybody for hanging in there. The questions that we didn't get to, Suzanne and I will have those, and we'll try to incorporate those into future programs and also our publications. And we'll follow up with an email. A couple people have asked for links to different things that are on our website, so we'll put that together and get it out to you with a link back to the recording so that you can share that with family and friends. And many people have also expressed the uplifting nature of this particular program, which is just great. I know that there's a lot of focus right now on XMRV, and we feel it's really important not to lose sight of all the other important studies that are going on. So thank you, Suzanne, for helping us get back informed about those and to feel really, I think, hopeful about the very near future and what some of these developments will mean.
All right, everybody, keep the faith.
Okay, so long, and have a good rest of your day or evening, depending on where you are, and thanks again for participating in today's program. Bye-bye.